Howdy, folks. Thanks for checking into Mr. Ulrich's Land of Biology. I, of course, am Mr. Ulrich, and that's my son, Bruce. Hey, Bruce, tell me a story. Bruce loves a good story, and so do I. In this video, we're going to be introducing the concept of chemical equations and how we write down chemical equations and how they kind of, in their own way, tell kind of a chemical story. A long time ago, in a galaxy far, far away, there was this story of Star Wars, and I grew up with it. So A New Hope, of course, was the first one. Good story, right? And we start the story of A New Hope with whiny Luke at his Uncle Owen's place on Tatooine. And he's just, like I said, that's a whiny, bratty kid. And he goes through a transformation because of the conditions that were in place, right? Change because of the influence of Yoda and others, and he becomes changed afterwards and is now a Jedi Master. But there's the before when he was just a whiny bratty kid, and now he's a whiny bratty Jedi Master by the end of the story. We can describe chemical reactions and the equations that we write them as in much the same way. We have the beginning, what takes place beforehand. Those are the reactants or the reagents. We have an arrow that shows that some change is taking place, and then over the arrow write the conditions that are necessary for that chemical reaction, for that change taking place. And then when you're done, you have the products that you were looking for, as well as any waste products that might occur as well. Well, let's take a look at a science nonfiction example rather than a science fiction example. We'll pull this one right from the lab that you're either going to do this week or have already done, depending on where you are in this crazy hybrid schedule. But we'll take some glucose and some fructose, two simple sugars, and we're going to cause them to combine to form the disaccharide sucrose. Now, in order for this to take place, we've got to take a hydrogen off of one and an oxygen and a hydrogen off of the other, glucose and fructose, right, so that they have some bonds available, some places to actually bond. Because right now, they're totally stable. All of their carbons are happy, and their oxygens and their hydrogens are all happy because they're all bonded up. So we pull some of those off, and we're going to make sucrose, but then we're also going to take that hydrogen and oxygen and put them together and make water. So we're going to do some dehydration synthesis. Again, we're going to talk about this in the lab and in class. The important thing also for us to recognize is that if I take glucose and fructose and put them together and let them sit there, I'm not going to end up with a pile of sucrose. This needs to be catalyzed in order for the reaction to actually take place. And so we're going to have to add some sort of enzyme. And so those are going to be the conditions, in this case, the conditions of the reaction needed in order to cause glucose and fructose to come together to make sucrose. So I need some enzymes in there. And this is what you're almost always going to see over the arrow in a biochemical reaction because they all need some sort of enzyme. Here's another classic example of a chemical equation that you're going to see a lot of, taking carbon dioxide and water, combining them in the presence of chlorophyll and some light source to form glucose, that's C6H12O6, and oxygen. And hopefully you can recognize this as good old photosynthesis. And of course, every time you see photosynthesis, they always show you a picture of a tree. And so I'm showing you some algae because, dang it, we need to appreciate our algae since they're the ones that are making most of the oxygen that we're breathing anyway. Whatever, the important thing is that you recognize this as a chemical equation, as carbon dioxide and water being the reactants or reagents, the before, glucose and oxygen. Even the oxygen is the waste product, the glucose is the goal, but we put both of them in there. And the conditions for the reaction are written around the arrow. Well, we'll leave it at that. If you have any other questions, please feel free to drop it in the comment section or see me in class or drop me an email. You know how to get in touch with me. Other than that, I hope to see you in class real soon.